Just a quick question. How many of you were at my talk yesterday? Okay. And how many of you have built a ROM, compiled Android from source? Oh, wow. Excellent. Cool. So I'm going to attempt to squeeze what's normally an hour talk into 25 minutes. So I'm going to go really fast. And you're welcome to ask questions later on. So just a little bit about myself. My name is Marko. I work for a company called Maracana based in San Francisco. I'm an author of Learning Android book published by O'Reilly. It's also translated into German and Chinese. But that book is more about app development. What we're talking about today is platform development, making a custom ROM basically. So why would we remix Android? What's the point of doing that? So first of all, remixing basically to me means taking the existing vanilla components and changing them in some meaningful way so that the end result is something that it works better for whatever better means. One of the reasons why we would remix Android is because we can, because it's open, because custom usually is better, and it's possible. So that's a good enough reason. If something is possible, you should just do it. So what are we gonna remix? So in this talk, I'm not really gonna talk about cosmetics too much. I'm not overly focused on how to change a boot animation or replace the wallpaper. We're gonna do a little bit more. We're gonna register. We're gonna create a new device, and I'm gonna tell you how to do it properly. We call it Maracana Alpha. It's just a made-up device that we use for training purposes, explaining purposes. We're going to create the plumbing, makefile plumbing, and this tends to be one of the hardest parts when dealing with custom ROMs. We're going to build the device. We're going to add a custom kernel. We're going to add a native library. We're going to add a native daemon. We're going to add libraries for the JNI support. So we're exposing our native libraries via JNI. We're going to register it as a system service, and we're going to add the application framework support for it so that finally our new app can take advantage of all this plumbing that we built. And finally, we're going to build a custom SDK so that other developers can take advantage of what we added to the platform. So most of you have seen this type of a picture before. This is a very sort of high-level overview of the Android stack. We have Linux kernel at the bottom, and we have native layer application framework apps at the top. And I expect most of you have seen one version of this or another. I'm going to be using a slightly more detailed version of the same stack. And in this version, basically what I do is I explain where things are both in the source tree as well as on the device when it's all said and done, right, when you deploy it on the device. So it may be a small text, but this image is available on maracana.com, so you're welcome to get the full version, and I'll also provide this talk later on as well. So in a standard Android, we have interaction between layers, and basically at the top of the stack we have, this is your application, right? It could be a system app, it could be an app that user just downloaded. That application talks to something in the application framework. This is the Java framework that's elegantly exposed to us as app developers. That in turn may be talking to a Java service, one of the system services. There are about 57 of them in a standard ICS release. And that in turn may be talking to either a native daemon or loading a native library that may talk to a driver, a HAL, hardware abstraction layer, and ultimately go to the Linux kernel realm. So this is a typical interaction when you try to do something in Android. For example, if you're trying to figure out what your location is via GPS, that's basically in the location case, your app would be talking to the location manager, which would be talking to a location service, which is a system service, which would load either a location library, and it would use some kind of HAL to talk to the physical driver that's in the kernel space. So we're going to build one of those vertical stacks. This is another way to kind of look at that. So basically, in a typical Android space, you have a client, some kind of application, and that application ultimately is talking to some kind of service, right? That communication usually happens via something called binder, which is basically the IPC mechanism that Android provides. Our service may also use a native library to get the job done, so some piece of C++ compiled code. So we're going to take this picture and we're going to blow it up a little into a little more detail. So in this case, we now have a client here, we have a service here. So this is some kind of client application. The blue is Dalvik, so it's basically Java code. And this at the bottom is our kernel. And what we have is we have some kind of activity that is talking via a manager through the proxy, because this is how the IPC communication actually happens, to our service, which is then in turn talking to a native library, which in turn is talking down to the kernel. So basically we have a vertical top to bottom app to middle layer app framework to native libraries to HAL to down to the bottom of it all, which is usually a kernel driver. So we're going to build something like this, one of these vertical stacks, and we're going to explain it via this example, which is a simple logging service. So first, what you do is you download the source code from source.android.com, you build a source tree, you run it on a device, and off you go. One of the things that you need to know is how to properly set up the structure when you're remixing your version of Android. So basically, the source tree would ultimately look like something like this. You basically have everything that you just downloaded from the Android repository, and often people go and start sprinkling their changes all over the source tree. That's usually not a good idea because you want to future-proof your changes. Android is going to come with a new version of Android, then you're going to want to pull it down, and you will want to move your changes upstream with the new version. So the better approach is to basically create a device in the device directory. This is how Google suggests to do it. And so that's what we're doing here. We basically have this directory called Maracana because we're building this device called Maracana Alpha. So what we're going to do is we're going to keep that as the main directory for it. We're going to create alpha directory, which is for the stuff that goes onto the device, versus the stuff that goes into the SDK add-on, versus the stuff that's common. So this would be basically the shared code base. So that's basically how we organize the code in this case. So first thing first, you register your device. So there's a special file called vendorsetup.sh. You basically put a one-liner in that file that basically says what kind of a device you're registering for the build system, so for the Android build system. And when you do source build DNV setup, which is the first thing you need to do before you build the Android ROM, you will notice that your device has been registered in that case. So far so good. That's a good thing. Next, what we're going to do is we're going to create the plumbing for the make system. Like I said, this tends to be one of the most complex parts of the job. So basically what we're doing is we're creating the mother of all files, which is basically Android products.mk, and we're simply saying include our full version of this device. Because you could have multiple versions of your alpha device. It could be a full version, debug version, user version, etc. So what we're doing next is we're basically providing a couple of information about the device. So we're saying that this is a full release, the device name is alpha, and a short description is that it's some kind of Maracana alpha image that we're building. In this case, I'm focused on emulator, but these steps are exactly the same if you're building for a physical device, such as Motorola Zoom or something like that, or Panda board. So next what we do is we copy the boilerplate make files from another sample device directory. So in this case, I copy it from the generic because I'm using the emulator. If I was going to do for Panda board or Beagle board or something like that, I would simply copy the files from those directories. That's usually the easiest way to get started with this. So what we do next is we need to create the signing keys for the platform. You already have the keys in your source tree, but those are not going to pass the CTS. So you need to create your own keys. So first thing you do is you define the signer. So this is basically what we're saying is that we're based in the US, California, San Francisco. Company name is Maracana, and this is our email address, which should probably change. And then we need to remove the existing keys. So there's a directory called build target product security, and you just delete all the files that match the pattern there. And then you start creating your keys. So first we're creating a platform key. Again, This is a tool that ships with the source tree, so it's fairly easy to use, and you just basically run it and you create that key. Through that, we create a shared key, the same steps. We create a media key, the same steps, and we generate the test keys. So there are 4 keys that we need to create. And finally, we verify that everything is there. So we basically just check that all the files are there. We just basically can then make sure that we have the proper issuer specified, and that all the keys are there. Keep in mind that these keys, you probably want to keep them safe because they're your private keys, so you want to guard them as such. So we build a device. So we basically source, build DNB setup. We can verify that indeed we're building ice cream sandwich, that we're building that release, and we're building for ARM in this case. We turn on USC cache so that it runs faster, and we finally run it to make sure that we have a build. And as you can see, we can verify that this is really the device that we just built, and it's got the model number that we put in. So that's basically it. So far vanilla. We haven't done anything. So the first thing that we do is we modify the kernel. So we're going to be basically modifying bits and pieces of this vertical stack. So the kernel, the kernel fits in this place in the picture, just to kind of give you another perspective. So basically what we're going to do is we're going to create a directory, we're going to git clone kernel, we're going to check it out, we're going to build it. So in this case, I'm not really modifying anything, I'm simply compiling vanilla kernel. I copy the kernel into a specific place that goes into alpha common, so that's where it's going to live. And we then specify in our board config that we're using the kernel. This is a double negative, so watch out for that. So, and finally, what we do is we add to the alpha make file that we want to copy that kernel into the final release. So that's how we get the kernel into the build. What we do then is we make sure that we include that file, and we then run it on a device. And we can verify that at this point we really indeed have the custom kernel in our version of Android. So in this case, like I said, we just basically downloaded the basic kernel and compiled it. But if you want to modify it, you would just go and modify kernel, whichever way you like. So the next thing that we're doing is we're adding a native library. So this is where it fits in the picture. So basically, our native library is both part of the service, because the service uses it, but we also have a daemon code that's going to be using the same native library. This is where it's going to end up in terms of the stack, looking at through a different perspective. So what we do is we create a directory where we're going to keep the library. So it's going to go into common because it's shared between various both device and the development tools, etc. And we're going to create a directory called lib. We create the top level makefile. This is the makefile that's going to include all the other makefiles. So that's one of the types of a makefile. We create a directory for our library, and we then create a header file because we're going to need to expose some of the library functionality, ideally eventually to JNI. We then implement that library using IOCTL call. So like I said, in this case, we just wanted to showcase how you can actually make a kernel call, and one of the kernel calls is the IOCTL call for flushing the log file system. And we create the makefile. This is a typical makefile in Android. You almost always have these 2 lines of code at the beginning, and you always have the final line, something like this, where this may change. It could be build shared library, build executable, build package, build module, etc., etc., depending on what the output of that is. So these makefiles you see all over the place, and it's always called Android MK. What we do in that makefile is we make sure that we add this library into a package. So just building it is not going to necessarily release it into the final product. What we then do is we run it to make sure that it's built. So we make it, and we can see that this is actually being compiled and linked and all that stuff. So the final product is released as the log.so. So what we're going to do next is we're going to build a native daemon. So it's going to fit into this part of the stack. It's going to be calling that native library. So we create a directory. Again, it goes into common, but in this case bin, not lib. We create the top level makefile, right? the one that we always need. We then write our C code, and we create the makefile. Again, makefile is the same. 2 lines at the top, build executable is the target. Again, we need to register it with the product packages, otherwise it doesn't get copied in. And in this case, what we also do is, to have this daemon start, we need to add it to the init.rc file. And in this case, there are a couple of ways we can deal with this. I chose to copy the existing init.rc and modify it. So I copied the init.rc into our common directory, and I modify it by saying, hey, start our service at boot time. So when the kernel runs init.rc, it kicks off our service as a one-shot and runs it as a system user. And what we finally need to do is we need to tell the make system that we need to copy this init.rc into the final image. Otherwise, it's not going to get copied in. We make it, we run it, and when we execute it on ADB shell, if I do ADB shell PS, I can actually verify that indeed my daemon is being run every, in this case, 60 seconds, right? So I can verify that this is indeed working. Next, what we're going to do is we're going to modify we're going to create the JNI around our lib, because ultimately Java is going to be calling this native code, so we need to expose it via JNI. So what we're doing is we are basically creating a directory. In this case, it's common framework, so we're creating a framework directory there, and we are creating the top level makefile, the one you need whenever you create one of these top level direct, like bin, lib, or framework so far. And then what we do is we write our Java. I did not include it here because it's too much information. But we write our Java code. We write our Java main just for testing purposes. And we add a permission that we basically specify that this library is, we request to use this library. This library is going to need to be copied into the system folder so that it can be later on loaded. So that's why we need to basically specify that this library is part of that. We have our makefile. In this case, makefile may look a little longer, but it's really 3 makefiles in one, right? So we do the 2 lines at the top, right? And then we basically, here we build the library. So the output is build Java library. Then we build the documentation needed for the SDK add-on, and then we built the XML, or actually just copy the XML. And we create the JNI header via Java h-JNI. That's our header, so we basically get those boilerplate code. We implement that header in a C file, and we then create a makefile. So again, 2 lines are the same. The last line is build share library, so the output is going to be an SO. We add it to the main makefile for the platform, and we compile it, and then we can basically run it. We can verify that if I run make main, I can verify that this is actually working by doing adb logcat. I can verify that that we can see this library and so on. So that was the making the daemon. So what we're going to do next is we're going to build the IPC mechanism to communicate back and forth between the client and the server. That fits into this part of the picture of the stack. So we're going to create the directory. Again, it's going to go into framework directory. We're going to implement the AIDL file. We are going to write our Java code, and we're going to specify that we're using that library again. And we're going to then create a makefile. Again, it's very similar to the one we talked just previously in the daemon when we had the sample code. We are going to register these files because they need to be copied over. So it's an XML file. And we're going to make this and verify that it all got installed, so that the jar file actually got correctly installed in the right place. Finally, we're going to implement the service. Service is going to go into this part of the stack. So what we're going to do is we're going to create a directory. In this case, it's an app, so it goes into an app directory. So we need one of those top-level make files, the one-liners. What we do next is we create the manifest file, we implement the Java, we implement some more Java, and then the make file, again, looks like that. Again, same 2 lines here. We're building a package. That's what you do when you build an application. And we're also specifying here that we're using some of those libraries that we built previously, the wrapper libraries, the JNI libraries. And finally, we add it to our make file. and we install it. So that's now installed on the system service. Finally, we have a client to create. It's going to go into this directory, so it's an app, it's an application, or basic application with a UI. So we create the directory for it, so it goes back into the app structure. We write our Java code, we create our XML code, and then we create a makefile that is creating the package at the end of the day. We add it to our packages list, so it gets compiled, and we make the system, and we finally can see that our application is now working. So this is our custom application that's now baked into the ROM, into the platform. And we now want to have a way for developers to be able to develop using our new system service. So we need to package all this into an SDK package. So what we do is we create a directory under SDK Add-on. And in this case, I'm just going to simply create a skin and copy some libraries over. So I am basically starting with the skin that's just one of the default ones. All we did is just add a logo just so we can actually see that it's working. So we do the portrait and the landscape version of it. And we then create a file that you need. It's called hardware.ini. And we're simply specifying the heap size in this case, but you can modify various parameters about your specific board that you have. And then there's another file that you must have is manifest.ini, and you specify information about your SDK. In this case, it's just the name, vendor description, API level. I guess that's important. And also the libraries that are part of this. So how is this SDK different than everything else? So you need to specify the libraries. We then specify in our stub what to include. So for example, the main Java class was there just to basically provide a test stub for us. So we minus it from the build. It doesn't need to go there. But the log library and the log libraries basically need to be there, so we do include it. Okay. We create a rather complex MK file. So this add-on MK file, and I don't have time to go into all the details of it. But you kind of get the idea of the steps at least, and we register all this into with our make system. We create the top level make file, we compile everything, and the end result is that you can verify in your Eclipse, for example, that indeed you have a new version available as an SDK add-on to compile against. So we can then, if I'm building all this, I can basically see that I can build with that add-on. And that's basically what our skin looks at the end of the day, with a custom kernel, custom build, custom model, and custom skin. So it's all customized about this one. So that's basically it in terms of how we modify this ROM all the way from the top level app down to the low level kernel space. And all the code and everything is available on maracana.com. So I actually have this entire thing in more detail as an article available. So feel free to check it out. And as well as the strawman implementation of this ROM is available on GitHub. So thank you. Questions?
Thanks a lot.